So the next thing we'll be looking at is array indexing. For that, let's just create another array random dot randint. You have 16 elements. Okay, we have created 3 by 2. Now we will create 16, which means 4 by 4. 3. There you go. We have an array of 4 by 4 randomly generated random numbers. If you remember, we have an x1 array, which is this. If you want to access any of the element, you can use indexing. 0 would give you 5, x1 of 1 gives you 0. So I mean, it starts from 0. The indexing starts from 0, 0, 1, 2, 3, and so on. Like if you are from computer science, you know. If you have been doing arrays for a while, and you know. So whereas in x2, which is two-dimensional, you can access the elements. Like, for example, you want to access an element from, by the way, the rows and columns are separated by a comma. So here, for this thing, let's access 2. So this is the 1 and 2, but the rows are numbered from 0, so 0 and 1 and 2. So 2 is on index 1, so 1, and it's on index 0 according to columns. So this is a row 0, this is the row 1, this is the row 2, and this thing here is the column 0, this thing here is the column 1. So you want to access 2, so it's on first indexing row and 0th column. There you go. 2. Like that, you can just experiment and play around and see which all the elements you can access. And similarly with x3, you want third, which means the, here we go, 0, 1, 2, 3. We want 8. So this is on last row, which is 3, 0, 1, 2, 3, and 0, 1, 2, row index 2, column index 3, we get 8. So in that way, you can just play around, practice this for a while, and you will get free at this. You can also change elements, like x2 of, what did we, 1, 0. So we got 2 here, which is this 2. If you want to change it, you can change that number, x2 of 1, 0. You can give it 10, and that would change. See, 2 has changed to 10. So in that way, you can replace numbers too. But if you want to, let us see this. Let us replace this 5 with a floating point number. x1 of 0 is equal to 3 point da da da, and then you print x1. What you can see is, since it's a fixed size numpy array, the digits after the point with the point are truncated. So we have given 3.222, and it has truncated that 0.222 from that element, because this is a especially fixed type arrays. So you cannot give numpy a floating point and then expect you can't expect numpy to add that number, and that is a mistake many people do. So be careful. So let us do array slicing. This was the indexing part, and now let us do array slicing. For revision part, I'll just create an array using a range function. Again, this is a range, and you want how many? 10. That's it. X, you have 0 to 9. So for slicing purposes in one dimensional, let us take this colon. This colon is used to mark to, from and to. The left side of the colon you mention the index from. The right side of the colon you mention the to index. For example, from 0th index to 5th index, if you do this, you will see that it has gone till 4, and this part here, because it will stop the index you will give to the 2 index you provide to that, the 2 index you provide in the slicing, the pointer will stop just before the 2 index, so it will give you an element before that element. So if you want that 5 also, you just have to, you just have to increase the index 6. Now you will get 5. You can access elements also from the last. For example, in this we will be using negative indexes, where -1, see, you access 9, whereas in -3 you access the third element from the last. So this is how you do it. And if you want to, eliminate the last one, so you can do like from 0. If you don't mention anything here, like for example, if you don't mention anything, it will take the whole array. See, if you don't mention anything here, and in the from section if you put -1, it will eliminate the last one, you see. So that's how you do slicing. You can just play around with these numbers and see for yourself. So the next important thing is slicing in two-dimensional. For example, we have x2 is a two-dimensional, x2. Now here the rows and columns are separated by a comma. You separate the rows and columns by a comma, and then here you want to put that colon from which row to which row, and after the comma you want to put a colon from which column to which column. Suppose I want from 0th row to 2nd. Remember, if you put 2 there, it will stop at 1, because stop at 1. So which means 0, 1 and 2, but this 2 will not be included in your slicing. In the same way, from 0th column to, if you put 1, it will take only the 0th column. So if you put 2, it will take 0 and 1. So this is the first column, 3, 10, 7, the second column 5, 4, 6. So pause and run your cell and tell me what you have got. Done. Yeah, do it. So let's run this cell and see. So you have got your mention from 0 to 2, that means 0th index and first index rows, and you have mentioned 0 to 2, again the 0th index and first index. So you would get only this, the upper part. You haven't mentioned this thing. If you put 3 here, then you will get the same, but what's the point? So let's keep it that way. It's 2, it's 1. So in that way you can again play around with these numbers and see for yourself, practice for a while until you get familiar. So one important thing about Numpy arrays is, when you slice the Numpy array using Numpy, so you get the view of the sliced array. Whereas in Python, if you slice the array, the copy, another copy is formed, another copy is created, whereas in arrays in Numpy, you don't get the copy. In that way you're saving the space. We'll talk about space complexity sometime in the course, but for now remember that numpy arrays would use views rather than a copy. So Python is creating a copy of your sliced array, whereas numpy is only showing you a view of that slice. So if you change anything in the view, it will be reflected in the original array. So be careful with that. To avoid this, you just create another variable where you can variable or another array, copy all the, save the original one, copy the original one into another variable or another uh, something, copy it and then use it. So this is a good practice, because in original data science projects you don't you don't do anything directly on the original data set. You make a copy of that original data set and then you analyze stuff on that. You change things in that. The original data is still preserved as it is. So you're just so you need to have this habit from now, like you copy that original array and then use its views and then change variables in that. So in that way, let us end this video here. I'll meet you in the next video. Bye bye.